Hi everyone, it's Paul. Well, we finally got to the malignant lesions of the cervix, and firstly we'll look at squamous cell carcinoma. Now there's no one feature that really helps decide that a lesion is malignant or not. So often it's easy to get to a diagnosis of high-grade cell, but in order to determine that it's a malignant lesion, you have to have quite a few other features, and often this is more of a pattern diagnosis than it is based on any one or two features. So we'll look at a few different cases, and I will guide you through why some of these are malignant rather than just high-grade cell. So first of all, the abnormal cells in the smears usually make up most of the cellular population, and often you have this picture, so crowded hyperchromatic groups, and I'm just cruising around here. You can see there's lots of dark small cells. They're arranged singly and in these loose groups and crowded hyperchromatic groups. So this would look like a pretty obvious high SIL on low power. There's a few normal cells around. There's a few features that suggest invasion possibly to me. One is these nuclei, so like that one over there, they have very coarse, irregular distribution of the chromatin, and that is a feature of malignancy that we've talked about before. So just looking around, and you can see there's some very high NC ratios here, and cells that would look like high SIL, and they actually predominate really. There's very few normal cells. This is a really nice example of what look like malignant cells to me. They have coarse irregular chromatin and prominent nucleoli, and those are features of malignancy also that you don't normally see in situ lesions. Another thing is necrosis and a tumour diathesis. This is a big clump of necrotic material, quite common in squamous cancers. And this is made up, if you look at all these bluey grey things, these are dead cells, and the nuclei have faded out of them, so you just have like a ghost of a cell. Often you'll have quite bizarre shaped orangiophilic cells like those ones in amongst the clumps as well. And the other thing you commonly see is just a lot of broken down blood. So that is fibrin and degenerate red cells. Again, nice malignant chromatin in those for me, coarse irregular chromatin. And notice you start getting pleomorphic cells too, like this spindle, elongate shaped nucleus. And often they're hiding in amongst clumps of that necrotic debris and blood. Again, you can see more of these cells just in here, and all this material is necrotic dead cells, broken up red blood cells, fibrin. This is what we call a tumour diathesis. And often a tricky thing is that this blocks the filter in ThinPreps, and so you get smears that are of really fairly low cellularity, and you have to go hunting for the cells. Often they'll be grouped together in what looks on low power fairly insignificant groups of cells, but when you go down on them, they actually have quite abnormal features often. These are very keratinized cells, typical of SCC, and there's some odd weird tails in them, and if you get an area that's good, you can focus and find, rather than nice round nuclei, you'll find quite angular ones. Often the chromatin is very opaque. It's a degeneration thing really. Notice how these nuclei have not at all round nuclei. They're quite elongate and quite dark staining, and those are almost spindle cells there. And again, they're clumped in amongst all that debris and necrosis. Quite abnormal looking nuclei there, and that one that's got 3 nuclei and a tail. And then pleomorphic cells that are orangiophilic and heavily keratinized, like this weird thing, are very common in well-differentiated areas of SCC. You can see this is staining intensely orange. Another one here, that's probably 2 cells that have that heavily keratinized cytoplasm. This case is a fairly typical one. So we've got clumps of quite small cells with very coarse dark chromatin. That one there is an elongate spindle type cell, and they're hidden away amongst all of this debris. and so they take a bit of searching for. It's important that if you see that low cellularity, very dirty appearance, see there's another fibrous one hidden in there, that you go looking for these abnormal cells. So in summary, the appearance of SCC in ThinPreps is in single cells and sheets, crowded hyperchromatic groups, just like high cell, often clumped into little areas with necrosis. Cytoplasm varies from being very thin rims, such as a very high NC ratio like high cell, to those ones that we were just looking at, the orange ones that have really quite a low NC ratio but a very pleomorphic shape. Cytoplasm, especially on the more differentiated cells, is very squamoid, so it's got a well-defined border to it, it's dense, and it can be extremely refractile and orangiophilic. Often you'll see bizarre shapes, tadpoles, spindle shapes. The nuclei tend to be centrally placed unless it's a weird chordate cell. Nuclei typically are variable, enlarged, hyperchromatic, and have irregular nuclear membranes, may be spindled in shape, and have coarse, uneven chromatin, and sometimes multiple nucleoli. So, in summary, differentiating this from non-invasive lesions relies really on recognition of necrotic background, that's a tumour diathesis, on the predominance of abnormal cells and the sheer number of them, a variety of cell types, so not just poorly differentiated cells like in high cell, but also those orangiophilic chordate cells. Often the nuclei are different too, so uneven chromatin patterns and nucleoli are much more frequent. They are seen in high cell nucleoli, but not nearly as frequently. And all of this varies in case to case. Sometimes it's quite an easy malignant diagnosis, sometimes it's not really possible. And in those cases that are kind of grey area in between, we will often report high-grade cell with invasion not excluded, so that the patient can be seen to perhaps more rapidly, but it conveys, I guess, some doubt on our part as to whether it's invasive.